In this presentation, we will be discussing some of the most prominent differences between the two common processor designs, complex instruction set computing, or CISC, and reduced instruction set computing, or RISC. A topic of much historical debate, these two designs differ vastly in structure, methods of execution, as well as usability. In order to understand the differences between CISC and RISC processors, we will cover the basics of what a processor is and what it does. A processor, also known as the Central Processing Unit, or CPU for short, is where most of the calculations are processed. A CPU does four primary tasks: fetching, decoding, executing, and write back. The two types of CPU architectures we will be discussing, CISC and RISC, both accomplish primary processor jobs, such as decoding and executing. However, their approaches to doing so differ. In general, RISC has an assembly language that is designed so that each task is broken down into very simple instructions that are each executed once per clock cycle. CISC executes larger and more complex assembly instructions at a time. RISC instructions are highly efficient, but due to their simplicity, they result in many more lines of code, whereas with CISC, one instruction may equate to several RISC instructions. This results in simpler code at the cost of efficiency. These are not the only differences between the two architectures. As stated earlier, CISC architecture contains more complex assembly code, while RISC code is simpler. As such, CISC's minimal code is more programmer-friendly, but RISC tends to be more machine-oriented as the code is longer. Due to the nature of their architectures, CISC requires intricate hardware to compensate for its complex instructions, while RISC emphasizes on software due to the increased length of the code. Since RISC is simple, each line of assembly takes one clock cycle to execute, while CISC assembly lines may take multiple cycles. Take, for example, the process of multiplying two numbers together, which requires register loading, multiplying, and storing the resulting operand. A RISC processor needs you to list all of these instructions one by one, whereas a CISC processor can use the mult instruction to do this all at once. RISC-based processors are very common today, especially in mobile devices due to the power efficiency that they offer. However, most laptops use the CISC-based x86 platform since most laptops use Intel processors. Since CISC coding is also more user-friendly, this makes x86 a very prevalent CISC-based design. One interesting fact about the x86 platform is that it uses microcode, a lower-level machine code, to take advantage of some of the efficiencies that the RISC-based designs offer. The use of RISC and CISC processors in industry are dependent on associated costs. Early on, RAM was quite expensive, and utilizing less RAM was preferred. By designing complicated processors, a single line of code could translate to multiple instructions. This reduced the amount of RAM usage. However, multiple clock cycles resulted in heavy power usage. The RISC architecture seemed like a viable solution to this. It used more registers within the CPU, and thus reduced the use of RAM. The Spark processor is an example of this early success of the RISC architecture. Until the early 1990s, it seemed as though RISC would become the industry norm. However, CISC processor manufacturers started implementing RISC-like features. Many modern processors today consist of the CISC-RISC hybrid. Yet RISC processors, such as ARM, are still common today. Their simple structure allows them to be diversely integrated and also power efficient, which is of paramount importance to today's mobile technologies. To summarize, the main difference between CISC and RISC architectures are their approaches to coding. CISC assembly language is more complicated than RISC assembly language, while RISC assembly language relies on simplicity. While CISC software is more compressed than RISC, the trade-off is that CISC processors contain more complicated parts to accommodate the complicated assembly language. Today, many computers use CISC or CISC-RISC processors, such as x86, as CISC is considered more programmer-friendly, while smaller devices, such as phones, use RISC processors to conserve power. Thanks for watching our presentation of CISC versus RISC.